Welcome, everyone. This is not a Voices with Vervaeke. This is a new entity. Welcome, everyone. This is not a Voices with Vervaeke. This is a new entity I'm calling a video essay. But under good advice from the two gentlemen that are joining me, it was proposed to me, and I accept the proposal, that this should have a little bit more of a dialogical structure to it. And given the value of dialogue, as I've been explaining it in other work, I took this deeply to heart. I am going to present still an essay, and let's remember what Montaigne meant by essay. Essayer, to try. I am going to try, with the help of these two gentlemen, to bring some clarity to the issue around GPT machines, the advent of what looks like the first sparks of artificial general intelligence. I'm going to make some basic predictions, and then I'm going to get into the scientific value of these machines, and that will be both positive and negative, the philosophical value, the spiritual value, and then my proposal, given all of that argument and discussion about how we can best respond to undertake the alignment problem. So first of all, I'm going to ask the two gentlemen, two friends of mine, two people that I have come to appreciate, love, and rely on in increasing ways, that has only made my life and my work better. And so let's begin with Ryan.
Well, thanks, John. It's good for my heart to hear you say that, because you have been such a wonderful influence in my life as a YouTube student of yours and someone who has experienced a lot of transformation from your work, which has led me to be the executive director of the Vervaeke Foundation, where we are working to help to scale and bring about these solutions that you have pointed to so well in your work. And I also am the founder and run a technology services company called Mainstay Technologies. And technology has been near and dear to my heart and story forever. And the intersection of the meaning crisis, the meta crisis, and technology that is AI has me very fascinated, and been doing a lot of research on this and eager for what you are about to propose and argue here today.
Thanks, Ryan. Eric.
Yes, my name is Eric Foster. I'm media director over here at the Vervaeke Foundation. Much like Ryan, knew you before working alongside you, and continue to not only learn from you, but learn now alongside you as we work together on all the different videos and these essays and the conversations and everything. My interest in this primarily comes from, and I've told both of you this, I asked my mom the other day, I said, when was the first time you heard me really combat AI? What was the first time I started talking about it? And she said, I think you were about 8 years old. And for some reason, it's been a part of my life the entire way through. I'm now 30, so this is going on a long time of very just shallowly but continuously coming back to this idea. For some reason, it gripped me when I was very young, and I've been exploring all of the various different avenues that it could potentially take ever since.
Thank you. So the format's going to be the following. I'm going to go through sort of an argument per section, and then I'll open things up to take comments, questions from both Ryan and Eric. So the first thing I want to do is talk about the predictions. One of the things that are happening with the GPT machines is we're getting a swarm of predictions, and many people are finding this challenging because the predictions are quite varied. Many of them are inconsistent with each other, or even challenge each other in a fundamental way. I'm going to try and propose that we try to be more careful about the predictions. We try to steer ground between hyperbolic growth predictions, that these machines are just going to hyperbolically accelerate in intelligence, and that forks into two variations. Utopia is just around the corner, or we are doomed, forever doomed. And so let's be a little bit more cautious. I'll give you some reasons for that in a minute. We also want to steer between all of that, both the positive and negative hyperbole, and then a kind of stubborn skepticism that's digging its heels in and saying, nope, this is not AGI. It never will be. This is decades and decades away. And there are people making these arguments. And I think that is also incorrect. I think the attempt, for whatever reason, to dismiss these machines is not proportioning our evaluation to the reality that they are actually presenting to us. So what I hope is that we can get much more careful, and that getting more careful about the predictions we're making will also, in conjunction with the arguments and discussion we're going to have, allow us, and me maybe specifically, to propose some important threshold points that we have not yet met with these machines, but that we can reasonably foresee, not perhaps their timing, but why they are pivot points, and that these are points where we can make fundamental decisions about how we want to go forward, especially in terms of the spiritual challenge and the enlightenment issue. So why am I skeptical? Not about the machines. I'm critical, but not skeptical, and that distinction is going to be important throughout. I am skeptical of jumping to conclusions about hyperbolic growth, since human beings are famous for jumping to conclusions when they see hyperbolic growth. And if you don't believe me, just track the history of the stock market or something like that, and you can see that people can very often get taken up by it. What we can say is most often hyperbolic growth is found within self-organizing processes. And when hyperbolic growth is within self-organizing processes, and the economy is a self-organizing process, it usually is part of a larger pattern called punctuated equilibrium. You can see this also in the history of evolution. So after the asteroid hits, there's just exponential speciation in geological time, but time scales matter, and we'll talk about that later. And then it flattens off as the niches get filled, as constraints emerge, as more. So we don't know yet if this, like when people just draw these graphs, look at what's happened over the last 5 weeks, right? It's like, yeah. And then you need to remember, we got similar predictions about self-driving cars and the exponential growth, and soon all these people would be put out of work. And that was like 2012. We're 11 years later because we hit a plateau. There was the exponential growth and we hit a plateau. Now, I could be wrong, but the reasonable thing is to be agnostic about the meaning of this very low resolution measuring of exponential growth. I mean, here's another example. Consider if you were at the beginning of the 20th century and measuring all the breakthroughs in fundamental physics, and you would see this exponential growth, relativity, quantum mechanics, and then it plateaus. It plateaus, and it's been 50 and more years since we've had a significant breakthrough. We don't know. We don't know. And that is where we should properly stand about this. So we have to, instead of making predictions that are not well warranted, we should try and foresee plausible threshold points, not predict necessarily their timing, but foresee them, and foresee them as our opportunities to steer this in a powerful way. This is the alternative I'm proposing. See, as you get into exponential growth, things are often disclosed that you did not foresee within your normal framing. Let me give you one more analogy on this point. Traveling faster and faster. We could travel faster and faster, and here's an exponential growth in our ability to speed through the universe. Well, as you do, microparticles become relevant in a way they are never relevant for us in our daily movement. Right? There's a video online of what happens if a grain of sand hits the Earth at the speed of light, because force equals mass times acceleration. So it's accelerating to the speed of light, and it hits the Earth, and you have this titanic explosion. This is why interstellar travel might actually be impossible for us, even if we get machines that accelerate us towards the speed of light, because things that weren't constraints can suddenly become constraints. And of course, the speed of light constraint is also there. For all the fiction around faster than light travel, it's a real constraint. Again, this is meant as an analogy. We don't know what constraints will be revealed. We don't. And simply looking at a simplistic graph is not taking that into consideration. We are genuinely ignorant because, as I will make clear as we go through here, we really do not know how these machines are producing these emergent properties that they're producing. And therefore, trying to draw something like scientific predictions from ignorance of the underlying mechanisms is a seriously incautious thing to do. So we have to pull back from that. Now, I'm not saying we shouldn't try and foresee, but notice my shift in language. I'm shifting from prediction, at this date, this will happen, to foreseeing. What's the foresight? The foresight is, can we foresee, as we bring real explication to these, can we foresee threshold points where we can reasonably make a change? I think we are in a kairos. We are in a pivotal turning point in world history. Maybe one of the greatest, maybe the greatest. I don't know. I would need to be godlike to be able to make that pronouncement. But unfortunately, I'm not, which is something I'm also going to talk about later. I don't want to be a god. I hope you don't either. Imagine having a godlike ability to remember for all of eternity all your failures. I don't think that's an existence to be desired. So I think we need to be really careful. I think we need to pay attention to what we've seen in the history of science. The past century has not been the century of unlimited growth in knowledge. In some ways, yes, more and more data, more and more information, but you can be misled by just a quantitative approach. Because if you pay attention to what's been happening at a philosophical, epistemological, having to do with the study of knowledge level, what you've seen is this has been the century of the accelerating discovery of intrinsic limits on what we can know. The realization that the Cartesian project of unlimited knowledge is not actually a possibility. It is reasonable to conclude, again, I'm not speaking timing here, I'm talking about trajectory, but it's reasonable to conclude that this trajectory will continue and show itself in this project as well. We are going to perhaps start to discover the kinds of fundamental limits on mind and its interaction with matter that were not previously available to us. And that will be welcome. But I think it's unlikely that the machines will just, in some simple exponential pattern, grow. One of the reasons I think this is because there's an issue of what's called general system collapse. This comes out of general systems theory. And the place where we have evidence for this is in civilizations, which represent very complex intelligence within sophisticated distributed cognition that's intergenerational in nature. So this is very powerful cognition at work. I mean, and if you stop and think about it, the GPT machines are basically just taking that collective intelligence from distributed cognition and putting it into a single automated interface for us. So if you think the GPT machines are very intelligent, you should think that civilizations are equally that kind of superhuman intelligent. That's a reasonable thing to conclude. What do we know from the history of these civilizations? They faced general system collapse. Why? Let's take it that reality is inexhaustibly complex, not just complicated, but complex, right? And it contains real uncertainty, not just risk, real emergence. And by the way, when you have real emergence, you have real uncertainty, not just risk. And all of these people are invoking real emergence when they're talking about these machines. So real emergence means real uncertainty. It means real novelty, okay? Now, so you place superhuman civilization intelligence into a complex environment. What do you see the system doing? Becoming more and more complicated, adding more and more components, bureaucratizing itself in order to deal with problems. But what you get to is you get this sort of fact. As you linearly increase the number of problems you're trying to deal with, the number of interactions within your system is going up exponentially. So at some point, managing yourself becomes as problematic as any problem you're trying to solve in the environment. And then the system gets, as it said, top heavy. It gets over bureaucratized and it collapses. Now, this is a regular pattern, regular, reliable pattern for the superhuman intelligence that we find in civilizations. I do not think it's reasonable to conclude that these machines will somehow just avoid that problem of exponential growth in inner complicatedness as they try to deal with real problems that contain real uncertainty that an inexhaustible environment is presenting to them. Now, that doesn't mean I can say, oh, well, they're never going to surpass us. John Vervaeke is not saying that. John Vervaeke is well aware already of things that can surpass him. And like I said, it's very clear that we have been relying on the superintelligence of distributed cognition that is distributed across people and across generations for millennia as sort of an important source of normative guidance to us. So these machines, it's not unreasonable that they could reach that level. And maybe, and we'll talk about this later, having a different substrate, the material they're built on, may allow them to go to different levels. I do not think, though, that they can just grow exponentially indefinitely. I think that is, we have no good reason, and I'm trying to make arguments here, for believing that. And that means we can think about these machines, however godlike they might be, as being inherently still finite in a manner that really matters to their cognition and their attempts to make sense of themselves and their world. And that's going to be an important linchpin later on in my argument. What's interesting is there's some evidence that we are very close to all the trade-off points, at least for biological beings. For example, there's all these U-curves for like if speed of transmission. If you speed up the speed of neuronal transmission, we're at sort of the maximal, sort of the optimal, because if you go too far, you get into diminishing returns, and the negative side effects start to manifest faster than the gains, and also for more neurons. And so I've seen some really good arguments that we're sort of peak biology. And that's very interesting if you think about it. That might be, of course, why we resorted to culture, because culture allows us to supersede the limits of peak biology. We teeter on the edge of despair and madness. And as these machines approach their own threshold, they will plausibly also teeter on the edge of that. And that is something we need to think about. And I'll give you more precise reasons as to why that is going to become important. It has to do with the increasing, these machines will have to increasingly rely on more and more pervasive disruptive strategies. And so we'll come back to that. All right. One more thing that I'm going to say about this is, and I'll go into this more detail, the rationality. Of course, we have to make and this is where the general systems things really starts to bite. These machines have to become more self-monitoring and self-directing in very powerful ways. And then the problem with that is if you make this system as powerful as this system, then you get into an infinite regress. One thing you don't want is a large language model, making all the hallucinations and repetitive actions and weirdness, trying to evaluate a lower order LLM that is making all kinds of hallucinations, repeated, because then you just get an infinite regress. So you have to properly have the heuristics operating at this level to be different in kind than this level. And that also gets you into a diminishing return issue, because at some point, you don't want this to become as complex as this. And think about it already. I mean, these machines have hundreds of billions of parameters. You know what it's like to try and track a 100 billion parameter system? One of the things that this machine that probably has more than 100 billion parameters can't do very well is track 100 billion parameters, right? And so just thinking that, we can just stack these on top of each other, I think is also overly simplistic. There's real trade-off relations, there's real problems there. And again, that means that these machines are going to be finite in a very important way. And they will confront, presumably, the issues around finitude that will be analogous to ones we have. Now, I want to stop here. I'm not finished this section, but I want to make clear all these gaps in the GPT machines, do not take them. I'm not offering them as any grounds for dismissive skepticism. I'm confident that we can approach these limits and that and we'll continue to make progress. And I'll point some of the things that are already happening. That's not why I'm doing this. What I'm doing this for is I want to show that these machines are not yet fully intelligent. Nobody really thinks that. They talk about sparks and the beginnings, but I want to unpack that common claim. It's unlikely that they're currently conscious. And what that means is we face thresholds about qualitatively improving, not just quantitatively, qualitatively improving their intelligence, possibly making them self-conscious, rationally reflective, etc. And that's what I'm most interested in. What are the threshold points